Hey, students, you are here in AP Physics 1. It's summertime, and you're having a summer assignment we're going to be talking about. Now, a lot of that stuff that you see at this point so far, some of this stuff is material you are familiar with, but we're just going to kind of hone up on it a little bit on it, and we're going to start with sig figs. Let me just kind of give you an example. If you remember sig figs, I'm just going to throw these out at random. 5.80, 4.900 times 10 to the 33rd, 45 desk. All right. Let me do this one, 0.0080. All right. Sig fig rules can be found if you would basically take time to, that was desk, excuse me. If you will take time to look up the rules, if you need to hone up on them a little bit. But if you remember taking a look at this, is 3. This has 1 sig fig. This has 3 because that's significant. Here, if you have this is considered 4 sig figs. 45 desks, that's an exact number. So we say that's infinity. These are placeholders. And so this gives me a 2. There's 2 here. Now, if I did this, 1.0080, we count them all, and we have 5 there, okay? So now that we know that, I'm going to try to, actually, I'm going to move the camera up a little bit. Let's see, just a little bit closer. We're going to see how this rolls here, right? All right, so let's go on. What's the rule for multiplication and division? If you'll take time, again, you can look up the rules. You've already had these before. And I may have to trade out markers here, so hang tight here. So watch what we're doing here. Let's suppose we want to add or subtract. The rule for addition and subtraction are the same. If you have 2 values and you add them together, you want to line up the decimal. All right. Rule is addition, subtraction, line up the decimal. So I get 8.959. Now, if you'll notice, where's the first stop? Boom, that's the first stop. You go down here, and we go to the right. All right, it's 5 or greater, so this bumps up 1, which is going to carry over, and you get 9.0 is the correct number of sig figs. All right. Now, the rule for addition and subtraction are the same. You line up your decimal. The rule for multiplication and division looks like this. You go by which one has the least sig fig. So if you have 14 times 4,735, well, I got to get my handy dandy calculator out. All right. So let me adjust my microphone. I'm working on it here, working on it. Oop, my batteries are low. 14 times 4,735. Here's what I get an answer of: 66,290. Which one has the least sig figs? Well, this has 2. This has 4. That means my answer needs to be in 2 sig figs. 1, 2. If I go to the right, it's not 5 or greater. So what I do is say 66. Now, 66,290, if I round to the nearest sig figs, does that make sense being 66? Now, I want you to think about this. Let's suppose that I borrow some money off of you, and I borrow $48, all right? Or no, let's say I borrow $1,000 off you, and I just want to round down to the nearest sig fig. Does that make sense? Hey, I borrowed $66,000 from you. And then say, how about if I just round to the nearest sig fig and I give it to you 66 bucks? That's not a very fair trade, all right? So remember, it's 66,000 is the correct number of sig figs, all right? So the rule is multiplication and division, all right, are the same. The one with the least number of sig figs is what you go by. Now, let's move right along here. So we've done that. So we just a brief study, kind of go over on sig figs. Let's briefly go over conversion. You remember how we converted different things? Let's suppose you have 500 kilometers per hour, and we want to convert that to meters per second. All right. Let's suppose I have uh, 2 meters squared, and I want to convert that to centimeters squared. All right. So let's just go ahead and start with this. Again, this is stuff you already know. So we have 500 kilometers per hour. Let's find the relationship. What's the relationship? We want to go from hours to seconds. Hours on top, 3,600 seconds on bottom. Notice hours cancels. All right. And now if I were to solve, I would get kilometers per second, but I need to convert that kilometers to meters. So what's the relationship between kilometers and meters? There's 1,000 meters in a kilometer. So what I'm going to do is on my calculator, take 500 divided by 3,600 times 1,000. And you should get 138.9 meters per second. I'm going to let you try that on your calculator. Okay, so if you did this on your calculator, 500 divided by 3,600 times 1,000, you should get that. Now let's suppose we want to convert. Now watch what I'm doing, the marks. I want to go from meters squared to centimeters squared. What is the relationship between the two? We know there's 100 centimeters in a meter. So 100 centimeters in a meter. Here's the deal. What does a meter squared mean? It means what? Squared, twice. So if I cancel that, I knock off one of those. So I have to do it again. This is just a reminder to what you guys already know. All right, watch this. Oh, got rid of the other meter. If I take 2 times 100 times 100 again, I'll just let you try that. 2 times 100 times 100. And what I get is 20,000 centimeters squared. All right. There are, let's do one more here. Actually, I'm going to do a couple more that I think are very important and critical to what we are doing. And I've got to do a better eraser here. All right. Let's suppose I have 400 inches. I want to convert that to feet. Folks, I want you to take a look. I'm sorry, let's correct this. Let's do inches cubed. There are 12 inches in a foot. There's not 12 cubic inches in a foot. All right. So watch what I'm going to do here. And there's 12 inches in a foot. Since it's a cube, I got to do it 3 times. Foot, 12 inches. Foot, 12 inches. Now, I'm going to press this to you. You need to set them up just like I've done here. All right. I don't want to see an answer. All right. And I'll show you here in just a little bit. You should show me this cancels, 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 cancels. All right. Oop, got to put 12 there. So what I'm going to do on my calculator, 400 divided by 12, divided by 12, divided by 12. And what I get is 0.23 feet cubed. All right. Now, here's what might happen. If you have 400 and you have this missing, you get no credit for the problem. You have to show work because on the AP exam, they grade your work. They do not grade your answer. All right. So let's kind of go through here. Let me do one last thing here for you. So we've done sig figs. We've done conversion. Let's go ahead and talk about, we're going to talk about relative error. So I'm going to make sure that we have all our topics covered for the first video. All right. So your first video is about conversion. It's about sig figs. And then the last idea is of error. Relative error. Relative error is basically how far off you are from the actual answer. Observed minus actual divided by actual. This is supposed to be absolute value. All right. So actual value means the accepted value or the true value or the accurate value. So here is an example, because this is really common that we're going to do this year. We're going to determine what the gravitational pull is here on Earth, and we're going to determine it experimentally. Okay, now here on Earth, the accepted value of gravity here on Earth is 9.8 meters per second squared. That's the accepted value. So here's the question. Let's suppose we do an experiment, trial 1, trial 2, trial 3, and we get these values. We get 7.5, we get 9.8, and then 10.9. Those are experimental values. Those are observed values. And this is also times 100. Sorry about that. Times 100%. So here's what I do. The observed value, 75 minus 9.8 divided by what? 9.8 times 100. You need to be doing these on your calculator. 9.8 minus 9.8. Oh, this is beautiful. We already know what? 0% there. And the next one is 10.9. That's 7.5. 10.9 minus 9.8 divided by 9.8, absolute value times 100%. All right, now I got to get my calculator out again. And the bad thing is I've set it down and I forgot what I did with it here. Okay, I tossed it here in my bag. Let me go grab another one here. Stuff happens, all right? So as we work here, all right, so I'm going to do this. The top one, 7.5 minus 9.8 equals, all right, now that I get negative 2.3, but you got to make it a positive. Divide by 9.8, and I get 0.23 multiplied by 100, and we are 20, I'll go one place past the decimal. 23.5% is the relative error for that one. 0% for this one. And the last one is this, 10.9 minus 9.8 divided by 9.8 times 100. So I get 11.2%. All right? But you'll always get a positive value for relative error, okay? So if you will look on your packet, you will see what I've done here. I've given you some work here, all right? That's the first page. Now this is practice. This is not to be tried, and I actually did a couple examples for you, all right? Here's the second page to your practice. This is not to be turned in, all right? So, but I want you to practice this. But here's the deal. I'm going to actually move my camera over, so you bear with me here. As I move this over, you see my thumb or whatever. I think you see my thumb, okay? So with that, because we're going to try to get a better shot here. Now, the conversion practice that I just showed you, hang tight here. I'm almost with you. You're almost with me. If you take a look here, I told you these are the sheets, okay? This is practice. You don't see anything written about turn on. This is for your practice. However, what I have done here is I was nice enough to I'm going to give you some answers because I want you to practice these, all right? And I'm going to just flash these for a very short time so you can stop your video. If I can hold that still. Let's see if I get a good picture. All right. You can always pause it. Let's see if it's better out there. All right. Right here, the rest of the answers. Again, I apologize. Whoop. Hey, we got some. Yeah, there we go. There we go. So that's page 1. I just showed you all the answers. You're just going to have to slow everything down. All right. And 2, take a look at this. Answers there too. All right. Going to scroll up so you can pause. Let's see. So that last one, the answers are 58%, 0%, 25%, and 63%. So there you go. All right. That kind of gives you a good start on things. All right. So one thing we're going to find out, physics is fun, but we've got to have some, we got to get some basics down in here. Okay. And I think AP1, we're going to hit the ground running. We got a lot of good physics stuff to do. I mean, really one of the first things we're going to do when you get into class, and follow what the syllabus I gave you for the summer, get that done. But we're going to determine the mass of the air in the classroom. and using the density formula. So, hey, if you've got any questions, I've left you've got my email. I will get back with you. We can do a Zoom or whatever you want during the summertime. So I think I've covered everything. This has to do with sig figs, conversion, relative error. The next one is over vectors, okay? And you really need to pay attention to that. And hopefully you understand what's going on with that, okay? You take care and you have a great day. Love you all. Bye-bye.